Good evening. Thank you for joining us in today's session. This session is about the key technologies in Windows 8 that you should be aware of if you plan to build shopping applications on the platform. It amazes me every year when it comes time for holiday shopping, because shopping can actually become quite complicated. When I have to think about gifts to buy for my friends and family, I need to think about the product, the make and the model. I look at expert reviews, opinions from friends and family. I think about personal preferences. And there's a lot of decisions I need to make as a customer. So as application developers, we want to make sure that the application we build is streamlined and helps customers get through all those decision points and close the sale. That's what we want to talk about today. We want to talk about the functionality in the Windows 8 platform that you can leverage in building a compelling shopping application on Windows 8. My name is Santosh Panchap, and I am a program manager with the Windows Partner and Ecosystem team.
And I'm John. Santosh and I have the easiest to pronounce pair of names in the Build conference this week. So one thing that you're going to leave with is how to pronounce our names. I'm John, and I'm with the Windows Apps team. The next. So today we're going to do a few things, and it's going to be a tech talk. So we're actually going to see code. This is a part of the shopping track. So we had Mark Hopkins' talk about designing shopping apps earlier today. So this is a second session talking about the technology behind some of the features and design decisions that we talked about. So we're going to do a few things today where we're going to talk about some architectural decisions, talking about how to show large lists of data. We're going to talk about how to authenticate and communicate between web and app. We're going to cover a little bit of payment methods, and actually we're going to have a special guest where we're going to have a demo from PayPal about the about today's announcement, where PayPal is now a part of the purchase flow in Windows apps. And then we're going to go through a set of features that you should think about as you're building a shopping app, and see code, sample code running through those examples. So at the end of this session, you should be leaving with a knowledge and the code to address some of those unique challenges in building shopping apps. Because we have a lot of things to go through today, I would like to ask if you have questions. Let's leave it towards the end, unless it's really burning and really going to change the course of this presentation. And then we're also going to be available at the networking lounge after this meeting to answer any questions and meet up with you guys. So as we think about shopping apps, and this is sort of a recap of what we just talked about in the Mark's session, there's a set of things that you really need to think about. These are sort of the core parts of for shopping apps. Number one is, in most cases, you have a really large set of data. When we search for shoes on the eBay app in the previous session, we found 3 million shoes to choose from. So how do you show those? How do you filter through those? Then we're going to talk about user authentication. We're going to talk about how to actually get paid, kind of important for shopping. We're going to talk about sharing and the idea of having a wish list that you can keep of in an app and use the share charm to do that. Then we're going to talk about some notifications. And if time permits, we're also going to talk about receipts, which is actually one of my favorite features. So with that, what we want to start with is there's a lot of web showed us shopping can be a lot of fun. It could be cheaper. It could be really all digital. And one of the things that led us to do is, starting with the 1990s, shopping is becoming more and more prominent on the web. So as you think about building apps, you really don't want to start from scratch. What you instead want to do is figure out all the components that you can reuse in your Windows app. And now Santosh is going to talk about some of the ways to reuse the web components.
Thank you, John. So on the screen behind me, you can see two models of a shopping experience. The one on the left is a Windows Store application that is hosting an iframe. And within that iframe, you have a website. And on the right, there is a native Windows Store application that is hosting the same web assets, but within the Windows experience. So in the next couple of slides, we're going to drill down on these experiences, and I'll speak to what I think is good about it and what I think is challenging about it. But let's keep in mind a couple of important points. To the customer, the shopping application is the face of your business. That's what they will take away and associate with your brand name. So you want to give your customers the best experience in the shopping application. And at the same time, as application developers, we have limited screen real estate. So we want to make best use of the space that we have, and we want to present a very streamlined flow through the buying process. So this is the website hosting process, the model in which I have a store application that has an iframe that then hosts a website. There are a couple of challenges that quickly surface. As Mark mentioned in his talk, this is not a very touch-friendly interface. The touch targets are not far enough. And so chances are that customers will hit the wrong link. Also, it's a very confusing interface because you don't want to give customers a redundant search bar, a redundant command bar on top, and then choices on the left of the screen and additional links on the right. Because, as I mentioned before, the customer is going through a decision-making process. So you want to give him just the information that he needs that is relevant for his product buying experience. And Windows 8 gives you a lot of this native functionality built in. So you can swipe and bring out the search bar, you can bring out the app bar, and we'll get into that momentarily. The website does not natively support semantic zoom. Semantic zoom is when I'm looking at a collection of objects and I can zoom out. Because I have zoomed out, I can now see semantic information about those collections so that I can take a step back and then drill back down into the information that I care about. Websites don't give me that information. Also, the user interface is sluggish because I'm rendering a lot of information on the web page. There are also technical challenges here. The application that is containing the iframe does not really know what the customer is doing inside the iframe. So the customer might click on a link and get navigated to a totally different site, and the outer application will not know that. Also, if your application tries to execute unsafe JavaScript code, it might potentially crash. And the JavaScript code that is hosted from a web context cannot call the Windows RT API. If it tries to do that, it might crash as well. So I'm now going to demonstrate how you can do this in an iframe, but I should first point out where we recommend that you use this model. We recommend that you use iframes to host information within your store application when the content is the secondary actor for the experience. For example, think of terms of use or license agreement. That's a lot of static text with few controls that the customer can actually navigate to. You also have the option to disable those controls through the WinRT API when you host it. So that's when we recommend you actually use it. And I'll show you in a demo right now how you can go ahead and do that. But first, here's the experience we just spoke about. My Windows Store application with a iframe. And so as you can see, I can click on links and I can navigate. I should be careful when I do this because it might crash. I don't have a back button, so I can't really go back to where I was. But functionally, it is possible. Here's an example of a remote asset that I'm presenting within the shopping application. So I can scroll through the terms of use, and the customer can't really be playing around with a whole bunch of controls here. So the experience is very predictable, and it is not the primary actor in the scenario. I can also load local pages that are packaged with my application into the same iframe. And I'm going to show you here that I have a button within this iframe. I can interact with it. I have a button outside that iframe that I can also interact with. Notice that when I push the button outside the iframe, it's actually sending a post to the content in the iframe, and it's receiving information back out. So I have this form of communication. What's happening behind the scenes is that I'm calling JavaScript code from the parent container, which is my application. Now, if I was to navigate to a website that didn't implement that JavaScript code and then try to call this, the application will crash. And I'll show you how that happens. In Windows 8, essentially, it terminates your application. So it's crashed here. Switch, please. Thank you. So we'll run through some relevant code now. It takes just one line of code to host an iframe, and this is both in XAML, the Extensible Application Markup Language, in the .NET world, and in the HTML world, if you're using JavaScript. In this case, I'm defining the iframe, I'm specifying the dimensions for it. It takes one line of code to set the source of your web view, the iframe, and also one line of code to invoke script. Now, this is the other model that I want to talk to you about. This is the native store application model. And when you think about this, it helps to think about how native apps are developed. If you look at a standard desktop application, it has the file menu bar on top. Customers have grown to expect that from any application. So on a desktop application, I look to the top, and the commands that I frequently expect are there. Now, in Windows 8, customers are going to expect that those commands are going to be within the charms bar and within the application bar, because your application is not going to be the only application on the system. When Microsoft has put in a lot of research into how customers use their devices, and we've identified that there's generally two key buckets. You have what goes in the charms bar, which is like searching, settings, connecting to a printer and other devices. And you have context-specific commands that you can run on your application. Maybe you want to purchase an item. Maybe you want to provide feedback on an item. So we recommend that any app that is developed on Windows 8, your shopping experience leverages that platform functionality. And in doing so, you build a polished experience, and that is associated with your brand. A couple of other key concepts I should point out are the concept of chromeless design, so content first, and consistency with the user model, which is essentially all apps are following this paradigm. So this is best illustrated with an example. You've seen the web view model. I'm now going to show you the Windows Store. And in the Windows Store, it's just like your own store, right? I can see categories of products that I can buy. I have semantic zoom, unlike in the web view, so I can zoom out. And so now I have semantic information on each category. I can drill down into a product I want to buy, and I have that right in front of me. I can search for an item. I can share an item that I like. I can print it. I have settings for the application, and also on the app bar, I have the context-sensitive commands that I can execute. Thank you. So this slide essentially communicates what I just said. You have the bars that you can pull on demand, the charms bar and the application bar. What is happening behind the scenes is that you are still able to leverage component reuse, what John mentioned earlier, because we don't want to develop new code every time we write a new app. Instead, what we can do is leverage the same assets, but package them up within a way that it is still a native experience. So think of XML HTTP requests. I load an application which shows a lot of information, but that information is actually coming over the web. So I make asynchronous calls on the back end, which pulls the data, which could be pictures, it could be a title, a description, and then it renders it into a native view. So to wrap up this part of the talk, our recommendation is that you use web views, iframes with caution. Don't make that your primary experience for the app. If customers wanted to navigate to a website, they would choose a web browser instead. Instead, use web views as a secondary actor to help promote the primary scenario. Also, consider using these standard templates that we ship out of the box, because we've done a lot of work to make it easy for you to use. With just a couple of lines of code, you can use the charms, and you can use the app bar as well.
And as we keep talking about building a native app, one of the things that is really core to Windows, and this has been core to Windows since we first announced Windows to the public at Build last year, is that all Windows apps are content first, fast and responsive, and a fluid user experience. And this encompasses anything from the hub page that the user lands on to, all the way through the purchase flow and all the way to the time that they actually complete their purchase. So right now, Santosh is going to talk a little bit about how to do really fast and fluid list view experience.
Thank you, John. So behind the scenes, we've got a lot of data on a remote website. Recently, I was shopping for an item on the big stores, pick your store. And I type in a search query, and I get a lot of information back. That's because the website is trying to help me identify the product I want to buy. But along the way, there's a lot of code happening running behind the scenes. That information is coming from a database sitting somewhere through web services to my application. And we want to keep that responsive. So we have a background thread that runs to do the XML HTTP requests, pulls the data in, and then binds it to the user interface. So a couple of key principles that we would like you to keep in mind. The first is always keep the user interface thread responsive. So anytime you are running code that potentially is time consuming, do it on a background thread, and the best way to do that is with an asynchronous call. Consider using the concept of virtualization. Virtualization is where you use elements and you repurpose them over time. So typically when I get data from a remote source, I stand it up within a container. And in the .NET world, we call this data binding to an item template. So I have a list, and then that list has many items. I'm going to define that a particular item has an image, has a title, has a description. So I'm creating those elements. In .NET, I'm writing XAML, and in the HTML side, I'm writing HTML. Now, if I was to recreate these elements, each time I got new information from the web, then I'm repopulating the DOM, and the document object model, and I'm garbage collecting the elements that are no longer in scope. Likewise for .NET. Instead, the concept of virtualization is where I repurpose those elements. When they're out of view, I simply mark them as ready to recycle. I set the title, the description to null or to a default text. And when it comes the right time, I will repopulate those same controls with the information I've received. That is the concept of virtualization. We recommend that you keep item templates simple, because these item templates are repeated for every item. And when you have thousands and thousands of items to go through, try to minimize the computation that goes with each item template. Also consider loading subsets of information, because your customer is probably not interested in everything there is about an entire domain of products. So try following intelligent algorithms to identify what the customer is interested in. Try using a local cache. And when you use a local cache, and if you support filtering, then try to filter on that local cache first, so that you can quickly render that information, and behind the scenes you're running an asynchronous call, which is pulling filtered data from your remote site. So I'll now go ahead and demonstrate list virtualization with a sample here. Thank you, John. So this is a sample that I have repurposed from the build.windows site. The code is right there, so you can play with it. There is a concept of a renderer here, and that essentially is the code that is rendering the information for each item. Here I have a list view in grid layout. So the list view can be both in a serial list layout or in a grid layout. A list layout is great if it's in snap view, so that I can pan images top down. But each of the items here has its own item template. Here I've got an image with a title right below it. Now I can scroll through this information, and all this information is coming from the web. As you can see, we don't have network issues at this point, which is good. If I scroll really fast, you'll see that it hasn't populated yet. It's pulling that information down. This is the declarative template, where I have declared the structure for each item in my code. Now I can use function templates with recycling, which is my code is defining the structure for each item. It might be hard to notice, but this actually performs better. So it's able to repopulate it quicker.
I want to switch back.
So let's look at the relevant code here. In XAML, here's how I define the declarative template. So this is compile time definition. I'm essentially saying that each item in my list has a thumbnail and has content, which is the title. This is HTML, by the way, not XAML. And I'm also specifying the behavior for interaction with each item in my container. I'm specifying that it is a grid layout. If the customer was to swipe the app and put it in Snap View, then I would immediately change that to a list layout. Here's how I would do it in code. I'm just defining these elements runtime, but it still is creating new elements in the document object model. And here's the third approach, which essentially is I'm repurposing existing elements that I have defined. I'm just repopulating them with new information. So when they go out of the screen, I will reset them with default values. When they come back in, I will repurpose them to store the values I've pulled down. OK, so we're done with that part of the talk. And I want to now talk about user authentication. So when you try to connect to a service on the web, you generally need to authenticate and authorize. And in today's world, we have the concept of identity as a service. We also have a lot of shared services. About 2 weeks ago, I tried to write an application that would connect to my SkyDrive account, would pull my pictures down, and then render it in a flip view. But to do that, I actually had to authenticate and authorize with the service. And the service used my Microsoft account. Now, the interesting thing here is that my Microsoft account is used for a whole lot of other purposes. If you had my Microsoft account, you can log into my Windows 8 PC. You can check my email. You can check my calendar and whatnot. And that holds true for Facebook ID, holds true for Google ID, and for Twitter as well. So traditionally, you might have written applications where you own the user interface that shows the user input field for give me your username, give me your password, and then you handle that communication with the service. But there is a key drawback in that approach, which is that if the app I write is compromised, then the user is compromised for the entire service. And so in today's world, we have the mechanism of open authorization and open ID. And here is where we want to ideally authenticate and authorize a user without having to see their credentials. And it turns out that we have that in Windows 8. We have a component, an operating system level component, called the Windows Authentication Broker, the Web Authentication Broker. The neat thing about the Web Authentication Broker is that it will provide isolation between your app and the code that does the authentication and authorization. So let's say I was writing that app. I would not be asking the user to enter their credentials. Instead, I would call on the Web Authentication Broker. It would enable for me isolated credential gathering, and it would return back to me open authorization tokens. So now, if my app is compromised, the open authorization token is compromised. And for the purposes of that token, the service to that extent is compromised, but only for that specific period of time and for the scopes that the user has given the application access to. Now, if my app was to store and cache those credentials, then I also have single sign-on enabled. And that is per application ID. So I also have single sign-on enabled for my app, which is on my Windows 8 device, and on my website. So how does all this work? Behind the scenes, there are 3 key components here. The first is your application that needs to connect to a service to perform a certain scenario. It runs within a separate application container. The second, on the far right of the screen, is the Web Authentication Host. This is the OS level component that runs in a separate application container and does the credential gathering for you. In between, we have the runtime broker that does the communication between your app and the Web Authentication Host. I'll now run you through some steps that take place. This is a like 8 or 9 step process, so hopefully this will make sense. So here's how it starts out. Your application is rendering a service, and it decides that it wants to authorize the user. So it calls on the Web Authentication Broker, and it says, I want to authenticate this user, and I want to authorize access to a specific scope and for a specific period of time. Now your app will give the broker two pieces of information. The first is the website which will do the authentication. It could be a Facebook website, it could be Microsoft account, it could be Google. The second piece of information is a redirect URI. And this might be familiar to you if you understand OAuth already. But the two key pieces of information are, one, the website that will do the authentication, and the second is the redirect URI. Your website will run through a set of steps. It might show a terms of use. It might get the credentials, and all that is done in a separate app container. It will then redirect to that URI. So the broker now, it creates a new application container, creates a modal dialog, attaches that modal dialog to the web authentication host, and now you have the authentication host in a separate app container that has a UI now. And this is totally separate from your application. Your app is still waiting to hear back from the broker. Now the web authentication host has the UI. It navigates to the URI that you have provided, which could be Microsoft account or Google ID. The customer goes through a set of screens. It might just be, give me your credentials, or it might be, these are the terms of usage, click next, and then at some point of time they enter the credentials. And then there are two possibilities. Either the service behind the scenes accepts, authorizes the customer, or rejects. Either way, it is going to redirect the web, the UI to that redirect URI. And within the HTTP string, it is going to pass the OAuth token, or it's going to pass a failed response. Now, when the broker identifies this, it knows that the authentication authorization is complete. And so it begins the tear down process. This is where it starts, it gives the tokens to your app, and then you can use it for future service access, tears down the other application container, gets rid of any cookies. And so at the end of the day, what you have is authentication authorization that is independent of your app. Your app didn't have to see the credentials, but it has access to the service. So at this point of time, I would like to call up Eric Trott, who is with PayPal, a software engineer there, and he will show us how PayPal has used the web authentication broker to implement secure authentication. And this is not PayPal. This is not part of their demo.
Actually, do you have the diagram slide available? I think it's
the login. Yeah, I'll pull that in.
I'm not good at this.
Just hit one.
Great, thanks guys. Can everyone hear me? Put this up a little bit. So, Santosh, that very thorough description of what the web authentication broker can do. And the 8 steps seem a little, wow, that's kind of intense, but it's actually just one API call, which is pretty powerful. I know in C# it's asynchronous call, so you just let it do its thing, and you can continue your UI thread doing whatever you need to do. And invoking it through the WinJS library, it returns a promise. So it's really straightforward to use. You can provide it to 2 URLs or URIs, and the user interacts with it to do the rest. So what I'm here to talk about is how PayPal used it to essentially power our SDK. This diagram has a lot of arrows moving everywhere and a lot of layers, but the important layer, or the important piece for everybody here, is just the PayPal SDK part. Effectively, it's important that we protect our users' credentials. We don't want to put up a username and password dialog and say, well, this is on behalf of Facebook, and expect them to trust us. So Web Authentication Broker enables us to present something, in this case, a PayPal login. The user sees it, they recognize it, they can trust it. So that trust also needs to extend to the merchant developer. You guys, whoever's the merchant here, or whoever's developing these apps, want to make sure that you guys are safe too. Typically with checkout integration, you have things like an API account and API keys. And one of the things you don't want to do is embed your API keys in your application and then deploy that application to every user that downloads and installs it. So that brings us to this diagram. So what the PayPal SDK does is it uses this proxy service that we've set up to enable developers to approve a third-party merchant account to essentially perform transactions on your behalf. And then all you need to do, all you need to deploy with your application is your merchant ID. So it makes the API much nicer. You guys, to work with the PayPal SDK, don't have to do anything with a web authentication broker. That's hidden behind the SDK. You merely initialize it with your merchant ID and then invoke it, and it does the rest. So in the first iteration that we're going to be rolling out with, it's actually going to be interacting with our Express Checkout product, which is a very powerful, super easy to use product, and actually is not necessarily going to be something that the developer is going to be exposed to, other than delegating the rights to perform Express Checkout transactions. So I have a quick demo here. I guess, it was mentioned in the last session that taking users out of context is not good for conversion. So the demo is really quick, which is, I guess, good. So we'll give it a go. He hit number 3.
So, we're going to have a steampunk version of the
That's right.
Demo. Do you want to try quickly swapping between 2 and 3? It's the RGB mode. Ta-da!
Oh, sweet. So my demo is pretty simple. I don't know if anybody's done any messing around with any of the prepackaged templates, application templates, but this is just a split template. So we'll fire it up. I like to pretend that it's a new service with a paywall. So you get part of an application. I've gone into, you're going to go and select one of these items, and then I've got my Buy Now button. So assuming the internet connection is happy, hit Buy Now. Brings up the web authentication broker. I've got my PayPal login, so instantly recognizable by consumers. I log in. You can see here the price, whatever the price for this item was. This one happened to be 99 cents. So I can see it's just my product, quantity of 1. I hit log in. It's working. They'll have the opportunity to select their funding source. So right now, this one is just set up to use their PayPal balance. And then you hit continue. And, well, I should say the user hits continue. They interact with PayPal. PayPal performs the transaction on their behalf or on your behalf, and that's it. So it's pretty straightforward.
Awesome.
I guess there's one more point. Right now, or in the future, we'll be using the web authentication broker for what it's really intended for. And what we're looking to do is integrate OpenID, OpenID Connect, or OAuth support for use with the PayPal SDK. So that goes back to the secure credential, I forget what it's called now, the password vault. That's available through the Windows APIs. So it'll be a really powerful solution for enabling somebody to log in once and then be able to buy items throughout their experience with your application. So great. Thanks, guys. Thank you.
Thank you. Can I get the clicker somewhere? Oh, there it is. So we've gone through the demo. That was really cool. Thank you so much. One of the great things about PayPal is it's one of those really universal services that a lot of merchants use. And having that be available this early in the product, it will undoubtedly give a lot of people a leg up when they start building for Windows. So that's really, really cool. We're going to switch gears a little bit and talk about some of those things that Mark in his previous session talked about, that the Windows operating system features that enhance the shopping experience. And there's a lot of them, so we have a small subset of all of those that we're going to cover today. The first one we're going to cover is live tiles. So, if this talk, I didn't know when this talk was going to be before your Surface arrived or after. So because it's before, what I'll say is after 7 p.m. tonight, when you guys all play with your Surface, and for the web, I'm sure they all already have a Surface. When you play with your Windows devices, one of the things that you'll notice is live tiles. It's the first thing that you log into your computer. That's the first thing that you see. they're a really powerful way for any app to give ambient information about your app, about the things that are interesting in your app, to the user when they're not even thinking about you. And for shopping, this is really, really important because as one of the things that you're trying to do in a shopping app is to engage your users who actually cared enough to actually install the app onto their desktop. And your logo by itself, for a lot of the really well-known brands, it's an addictive part of it, right? All those daily deal sites like Living Socials of this world, people go there, go to their browser and type their address and go to those sites. But for a lot of others, it's actually really useful to take advantage of live tiles and show what's happening in your app today, so the user is more likely to click in and then actually see what your app has to offer. So we're going to talk a little bit about how you can have live tiles update with images from the web and get your users engaged with your app.
Thank you, John. How many folks in the audience have seen a live tile and know what it is? Okay, good. And there are going to be a lot of sessions on Build that focus on live tiles. But I'll show you one anyway, and this is going to be the quickest demo in Build 2012. To reconnect. And the demo is not done. Okay. So what you see on the top of the screen, the middle column, that is a live tile for the news application. And so every application can stream notifications to the tile that they own. You can stream notifications to a wider size tile or a smaller size tile. You have up to 5 live tiles that it will keep recycling through. So that's the concept of a live tile. But I want to talk to you about what I think is the most relevant part of this from a shopping experience. So from a shopping experience point of view, you care about sending notifications to your customers. So it's almost holiday time now. You might be in this mode where you're thinking about buying products. And stores are thinking about how they can reach out to their customers and notify them of upcoming deals. So on the screen here, I have four concepts, 4 components. The first is your application on the top left with the gear, the green box. On the top right is your cloud service. That's your store's service. And you want to be able to send notifications from your cloud to your customer's device. On the bottom left, you have the notification client platform, which lives on the customer's device. And on the bottom right, you have the Windows push notification service. So the scenario here is, as an app developer who's shipped a shopping application, there's an upcoming sale. I want to notify my customers about it. And so I have this remote service. I need to be able to send out this notification to my customers. And the notification could be text, could be images, it could be a badge, it could be a toast notification. But how does that happen? So behind the scenes, we need to get these four boxes talking to each other. When your app is installed, it needs to first request for a channel URI, a uniform resource identifier that uniquely identifies your app on the device for that user. So it requests that from the notification client platform. The notification client platform then turns around and asks the Windows notification service to provide a channel URI, and you get a unique URI back. So this is just like a HTTP call with a bunch of information in the back. So it's a uniform resource identifier. That is then passed back by the notification platform to your application. And now your app has a unique way to communicate with itself. So it gives that to your cloud service. Now this step 4 is you would need to implement, and it is strongly recommended that you do it on a secure channel so that it is not compromised. Now your cloud service has the channel URI, and it along with any other information that your app has given. Maybe your app has told the cloud service that this customer is interested in computers or in Windows. So those are the kinds of notifications this customer wants. The cloud service registers that along with the channel URI. Now, the cloud service, when it wants to send out a notification, reaches out to the push notification service. There's actually a hidden step here because we don't want any hacker spoofing your cloud service. So your cloud service actually has to authenticate with the Windows push notification service before it can send a notification. So when you register a application on the Windows Store, you will get credentials. You will get the package security identifier. You will get a client secret that you will have to keep to yourself. You will use those credentials to authenticate with the Windows push notification service, and then you invoke that channel URI that you were given. So you call that HTTP URI, and with your post call, you include a payload. That payload is an XML string, which contains the data that you want posted on the user's device. So that is that then goes to the notification platform and then back to the device on the live tile. So that's the big picture, and that pretty much sums up the Windows push notification service and what in my mind is the most relevant scenario for shopping. There's a lot more sessions on live tiles, so we won't drill down into that right now.
One of the ways that we think about charms is we talked about search earlier again in Mark's session, how powerful it is to use the OS search charm, because not only it allows your app to come up the list of searchable apps, but also it's a system-wide setting, meaning that even if I'm in another app or doing something else, watching a movie, playing a game, I can with just one flick and a search get to your app and see results from your app. Similar to that, Share is one of those really unique, interesting ways that drives engagement for your users, for your app. And the way that I like to think about for shopping apps, sharing can be a two-way thing. In number one, sharing is a great way to get your brand out, get your products out to a mass of people through the social networks of the user. So these are the things that we see on the web today when you have all those Facebook like buttons, all the Pinterest ones, all the Twitters, all the emails, name your social network. One of the biggest challenges for any web developer that's especially multinational is to figure out what to put on their website, which one of those social networks to put on their website. So if you imagine a multinational site that say, if you look at the social networks worldwide, India loves Orkut, Russia has their own set of things, China has QQ, and name your country, there's a social network that's popular. How do you address this as a web developer? What you need to really do is you need to figure out who comes to your site, do a little bit of analysis to figure out the top 3 or 4 social networks that you want to put onto your website so people can share your information out. One of the great things in Windows is not only it's a completely multinational, I don't know the exact number of markets, but I believe Windows is available in 200 odd markets already. Not only that you don't have to worry about which social networks that you can share, but the most powerful thing is all you have to worry about as an app developer is your data and how you want it to be shared. So Mark in his talk earlier talked about if you are an app that also has a web page, one of the most powerful things that you can share out from your app is a URL. So that if I'm sending Mark, I helped with your demo earlier today, so buy me this, I don't have to assume or presume that he is on a Windows 8 device. I can just share a URL that he can access to from any device that he has. Well, the cool thing is if he happens to have a Windows machine, you can use that app bridge that we talked about from your website and take him to your app. But that's sort of the gravy. The real meat, to take my turkey analogy forward, the real meat of the work is you wanted your app to share a URL so that anyone can buy stuff from you. The other thing about Share that's really powerful is in shopping, there's this idea of lists. People like to keep lists. People like to keep lists for Christmas. People like to keep lists for grocery shopping. People just like to keep lists because shopping is not, even though as shopping app builders, we'd like to think that people are just going to buy 100% of the time that they're in our app. More often than not, people actually like to think about it. And when they think about it, lists help a lot. So if you think about the share charm, not only you can be a share source, but you should think about the places that your app can act like a share target. So a great example of this is if you have the backend or if you have the capability to have a list of things, think about becoming a share target in which that you can accept, say, URLs from different sources and keep them in your app. so that people, the users, will come back to your app when they want to see that collection of lists. I'll give you an example. I won't have a demo on this, but I'll give you an example. In the store, there's an app called Pepperplate. A startup from New York built one of the earliest Windows apps. And we demoed Digital Folio earlier. Pepperplate is similar to Digital Folio in the sense that it's a recipe box app. So again, when you get your Surfaces later today, go install Pepperplate app and do one thing for me. Go to a recipe site. Go to one of the well-known recipe sites like All Recipes, Food Network, name your favorite recipe site. And when you're on a recipe site, invoke the share charm and select Pepperplate. What that would do is Pepperplate has built a cloud service that can understand the URL that you're passing to the app. The cloud service is smart enough to parse the information in the ingredients and the picture and how many people it serves, and then store it in the Pepperplate app. So what Pepperplate has basically done is giving you a place where you can hold a bunch of different recipes that you like. So as you're thinking about building your shopping apps, if you're one of those places that makes sense to keep a list of different things because you either offer better pricing or you offer better selection, or if you want your users to think that, think about the opportunities of becoming a shared target. So now Santosh is going to talk a little bit about the technology behind the share charm, so you can think about how you can build those in your app.
Thank you. So think about sharing from the world of mashups. So how many in the audience are familiar with what a mashup is, mashup of services? Okay, so the concept is that I have multiple web services. I want to be able to connect them. And when I write a web service, I don't necessarily know what it's going to be used for, because there's a world of potential scenarios out there. I write it for my scenario in mind, and then somebody comes along in the future and then hooks it up to something else, and it's magical. You get something like a mashup in Windows 8 right out of the box, because you can share data from an application to an application that you haven't heard of. So the way it works is that you have to define the package that you're going to share out and the data formats, and on the receiving end, the target defines the data packages that they can consume. So I'll show you a quick demo of how this works. So this is my mail. I've selected a string of text here, introducing Windows 8. And I'm now going to click on the share charm. So what this is showing me is the potential share targets. So there's at least three components at play here. There is your application. There is the operating system level component, which is triggering which is acting as a broker between your app, which is the source, and the target app, which is the consumer of that data. Now, the mail app itself has registered to consume strings. There is another sample I've installed here called the share target sample, and this is also on the MSDN site. The neat thing about this sample is that it will open up the data package for me to analyze. So the data that was being shared by the source in this case, I can see that it has a specific title, it has a description, and the actual HTML content that it contains. That is the concept of sharing. I can build data packages which contain images, which contain URIs, and I can share it to other applications on my machine. So in doing so, you have new scenarios that show up, just like mashups. So we have about 12 minutes, and I told you this might become interesting. So we've got a lot of content. You'll see us talking faster. Hopefully that is entertaining and understandable. So here are the three components: your source app, which is sharing, the share broker, and the target app. There is the concept of a data package that is created by your source app. When your app runs, it has to register a delegate. So it's telling the operating system, hey, you can call on me, and I support sharing. So when the user actually swipes and clicks the share charm, it calls on your delegate, and that's when you actually fill up that package, and you put in the text, you put in the URI, you put in the image. So then, now that your package is ready, the operating system starts to look for a set of potential target apps, and then that's what it shows on the view. So you can now look at all the apps. The user selects an app and then activates one of those as a share target. Now, the target app it understands that it has been activated for sharing, because within the code you can detect how the app was activated. So if you look at a typical Windows 8 app code, you can detect if it was activated because of a launching the tile, or if it was a share target, and so on. So it understands it was activated for sharing. It asks for the data package, unpacks it, and does its processing. Now, the target app might take a while to complete. So let's say that I shared 15 high-resolution pictures to my target app, and the target app was mail. So behind the scenes, it's now emailing all that, and it might take a while to complete. So it has a mechanism in which it can talk to the OS and tell the OS to keep it alive, so that it is not terminated, even though it goes into the background. So very quickly, what does the code look like? Here's how I initialize. There is a concept of a data transfer manager, which is the OS level component. I'm telling the OS that I want a data transfer manager, and I want to attach my delegate to it. Then when my delegate is called, the data requested handler here, I package up the information into my data package. This is what the target does. The target is checking to see how it was activated. In this case, it was activated as a share target. And so now it starts its job. It starts to unpack the package which it was given by the OS, and then it starts processing it.
That was really fast. That was good. So as we think about the charms, one of the charms that we talked about earlier, Santosh, when he described the charms, is devices. And the devices charm can have many things. It can have screens. It can have barcode readers. It can have printers. So today we just wanted to talk about printing because, in a funny way, it's just Windows, right? Like one of the things that Steven Sinofsky said when we launched Windows last week was, out of the box, Windows already works with more than 400 million devices, or printers, I think he said. So in a way, printing should be really simple. In another way, though, when you pick up a Surface, which is really light, or pick up any other device, pick your Windows device, which is really light touch enabled, the fact that it prints out of the box is a strange feeling. You'll get that when you first play with your one of those slates. The great thing about printing is, as you build your shopping apps, there are many scenarios. If you are one of those business models that have vouchers, think about the daily deal sites. Printing is a really core part of that. If you are doing things in your whatever you're building your app with pickups, where you buy online but you pick up from the store, then printing your receipt and taking it to the store becomes a really core component. Or if you're doing any sort of printing of receipts, again, or printing of tickets, all of these things that you do in a shopping app you sort of take for granted in on the web, there's a really robust way of doing that in Windows, and we're just going to talk about how that works through the printing charm.
So before we get to printing, it's interesting to note that there are a couple of components here that are at play. There is the content that I, as a customer, want to print. There is the application which is showing me that content, and then there is the actual printer. And there's a good deal of negotiation that's going on back and forth, because my printer supports some functionality. It might support duplex printing, it might support stapling, so it has a bunch of its own options. My application has its own functionality, because what I see on the page is not necessarily what I want to print. I don't want to print the content with Chrome. If I'm trying to print a web page, I don't want to see the browser there. I just want to see the text. And so the application has its own smarts. It tries to figure out how it should paginate that information as well. So with Windows 8, we have the concept of a broker for printing as well, also manifested through a contract. And I access the printing charm through devices. So I click on devices, and now I have a list of printers here. This is also where my soft printers would show up if I'm printing to an XPS file or a PDF. Now, when I click on a printer, I see a bunch of options that show up. There are default options like count and color, and those options are provided by the OS. But then we give the app developer the ability to extend that, because maybe you're developing a photo application, or or in your shopping application, you want to call out the expert reviews with the printouts. You know your customers best. So you'll include your own options here. And then the printer has its own options as well. So that's how it all shows up. So that's the demo there. And so how does it work? Essentially, just like sharing, you have a bunch of delegates that you attach. You have a contract that the operating system recognizes, and then you have the concept of a print manager with which you register your delegate. You have delegates for pagination, getting page previews, and spanning multiple pages when you want to print. Before we wrap up, we've got just a couple of minutes, but I want to point out that there are a lot of other scenarios that are possible with Windows 8. We just don't have time to get into all of that, but I'll highlight a couple of them. With single sign-on and Microsoft account, you have the ability to prepare a shopping cart experience on the application without even recognizing the user personally. So here's the scenario. I take my Windows 8 machine and I run my shopping application. I've logged in with my Microsoft account, but the application doesn't know who I am. I've just logged in with my Microsoft account. I can swipe, I can select 5 or 6 products that I like. I'll add it to my favorites. Now, if I launch my browser and go to the website that I got the app from, the website knows what's on my favorites list. It already knows that. It cannot personally identify me, but it is able to identify that it's the same user who used the app who is now logging into the website. There are many such scenarios. There is integration with SkyDrive for user data so that a user can store their receipts on SkyDrive and it becomes accessible across many devices. We just don't have the time to get into all that, but I strongly recommend that you join us after this session in Rainier, and then we can go through many other scenarios as well. In wrapping up, please consider your architecture carefully. When you use iframes, don't have that as your primary experience. Think about speed and responsiveness. Think about virtualizing and reusing elements in your DOM or within your .NET object tree. Security is critical. Customers, I know I do. I don't want to go to any random app and give them my credentials. I just don't feel comfortable doing that. I'd rather give it to the operating system because I'm confident that it is safer. There are a lot of features and functionality within the OS that you can leverage to build a compelling app, and you should be doing that because that's what your customer is going to associate with your brand. Thank you so much. There are related sessions here. One of these sessions has taken place earlier today, but I recommend that you watch it offline. That is Mark Hopkins' session on guidance for shopping apps. There are case studies coming up later in the day, and there's a deep dive on list views as well. Any questions we can answer?
In the minute and 20 seconds that we have? Go fast. All the way in the back.
I'll try a question. I'm just getting familiar with all of this. How does a user know that PayPal is the actual PayPal? Under a web experience, you have an extended validation certificate in your browser, so you see the green bar. In a shopping app, how does the user know that's actually PayPal?
And piggybacking on that, in the web you have a little gold key or lock thing that signifies it's a secure socket.
Yes. Okay, so the question was, how does a user who is using the web authentication broker know that it is really secure? Because if a customer was to do this on the website, they would see a green bar. It would say that it is potentially a trusted site. There would be a lock at the bottom on the screen indicating that it is a secure sockets layer connection. So how do you get that in with the web authentication broker? So the web authentication broker is a tightly controlled OS level component. When it shows up, it will present PayPal's user interface. That is you can customize that. And so ideally, what would be shown is the same interface that the customer is already familiar with. There are some potential technicalities that I'm not very confident of, so I think we should take that offline. But I anticipate that we can do some checking to see if this really is the site. But we'll speak to that after the session. I welcome you to join me and Renier to answer that question.
Actually,
by the way, the web authentication broker would use SSL anyway for communication.
And I think instead of taking the questions here, because we have a session coming up where Mark and I are going to be doing a little case studies on a couple of our shopping apps, I would invite anyone to go to the Rainier room where the Santosh and I will be present to take any questions that we have. We would love to meet you guys, unless we already have earlier. And so let's go to Rainier for a discussion and then come back here if you're interested in the case studies at 5:45. And we'll have a fine late evening session with the folks that are here. Thank you.
Thank you. Thank you.